A lamp produced a shadow of a man in the middle of a stage. How long is the man's shadow? So this is a hard problem because I can't just directly calculate how long this man's shadow is. It would be great, it would be easy if I could just use 19 as the reference angle and then use that to calculate the length of the shadow, but I can't because this triangle here, what I'm coloring in, this is not a right triangle. So I can't use our trig ratios on this triangle. Instead, what I'm going to have to do is figure out, with this reference angle, I'll have to figure out how long is the entire bottom side, and then with 21 degrees as my reference angle, figure out how long is just this side. And I'm going to have to subtract the two of those. That'll give me the shadow. So again, this is difficult just because I can't directly calculate that. If I use this as the reference angle, this will give me 40 degrees in total. And then labeling our sides, that makes this opposite. The longest here is the hypotenuse. And the third side that I've left over, this is the adjacent side. All right, so what I need to use here is actually tangent. I'm going to use tangent of 40 degrees. All right, so this, again, this is going to give me the entire bottom side of the triangle, which is kind of the first step to calculating his shadow. So if I set this up, this is going to give me opposite over adjacent, and adjacent is 15 meters. All right, from here, I need to calculate tangent of 40 degrees. I get 0.8391, and I'll just bring the rest down, opposite over 15. All right, and what I like to do from here is I put this number over a 1, kind of an invisible 1, and so that way I can cross multiply. And this works because I can divide any number by 1. It doesn't change the number. So here I can cross multiply this, right? So O times 1 is just O. And 15 times 0.8391 gives me about 12.59, maybe a little bit different just depending on your calculator or depending on how you round. All right, so that is the entire bottom piece of the triangle. What I need to also calculate, and I'll do this in blue, I need to figure out how long is this so I could subtract that from the 12.59. All right, so if I use 21 degrees, and I'll still use tangent, 21 degrees would be my reference angle just for this piece right there. Right, so tangent of 21 degrees, this will equal, I'll just say x. It's really still the opposite side. If the blue piece here, there we go. Let's call that x. So this is going to equal opposite over adjacent. Here opposite is x, and adjacent is still 15. All right, so tangent of 21, still the same number, 0.8391. And I'll just bring the rest down, x over 15. Again, putting this over 1, an invisible 1 lets me cross multiply. 1 times x is x. And 15 times 0.8391, this is giving me, let me see, I get 5.76. And again, you might get something just a little bit different depending on your calculator or depending on how you round, you might get something a little bit different. But these are my two numbers. So O is the whole bottom and blue is just this piece. If I subtract these, so 12.59 minus 5.76, this will give me my final answer of 6.83 meters. All right, so definitely kind of a tricky problem here. You have to do a little bit of thinking. You have to be a little clever about how you set it up just because we can't directly measure his shadow. Let's do one more. Kind of another hard problem here. So this says an exploration team is dragging a probe along the ocean floor. So here's your probe. Here's your team ship. The probe is traveling approximately 9,000 meters at an angle of depression of 64 degrees. The probe will be, how far below the ocean surface. So what's the depth of the probe? I'm trying to find, there we go, that's kind of a straight line, sort of. I'm trying to find kind of how deep is the probe from the ocean surface. So this, you might notice, is setting up a right triangle. with my reference angle of 64 degrees. So that makes the depth the opposite side. 9,000 would be hypotenuse, and then this side up here would be adjacent. All right, so for part A, I'm trying to figure out what is the opposite side? How deep is the probe in the ocean? So I'm finding opposite. I know what hypotenuse is. I want to use sine. Sine is opposite over hypotenuse. And our reference angle is going to be 64 degrees. All right, so sine of 64 is equal to opposite over 9,000. All right, and sine of 64, doing that on my calculator, I get 0.8988. I just want to use 4 digits for that just to be more specific. I'll put that over 1, so I can cross multiply with O over 9,000. Okay, so from here, again, just cross multiply. 1 times O is O, and 9,000 times 0.8988. This is going to give me, looks like 8,089.2. All right, so that's your answer for this. The probe will be approximately 8,089.2 meters below the ocean surface. And that's kind of your first part of the problem. For the second part, let's just look at what this is asking us. What's the horizontal distance of the probe behind the team ship? So here I'm trying to figure out, kind of how far back is this? What's the adjacent side? So if I have hypotenuse, I'm trying to find adjacent. Here I need to use cosine. All right, so cosine of 64 is equal to adjacent, and your hypotenuse is still 9,000. All right, and really I'm just doing kind of the same thing I did here. Calculate cosine of 64 is 0.4384. And again, I'll put that over 1 so I can cross multiply with A over 9,000, which is easy. 1 times A is A, and then 9,000 times 0.4384. This is going to give me 3,945.6. All right, and that's our answer for this part. Okay, so both these kind of more difficult problems, definitely more wordy than some of the other ones we've looked at, and definitely you have to think about it kind of before you set it up.